This is my first demonstration video in my series on embedded applications. This application is an OSGI application called ChargePoint, developed for a Swedish company called tingco. This application I am now demonstrating is an embedded GUI for an electrical vehicle charging station. Now at these stations you have these things called connectors, and you plug the lead from the connector into your electrical car, and you go to the GUI where there's a credit card swipe and a GUI where you choose options. This was created for a small Swedish company called tingco, who have since been absorbed into this larger company called Fortum, and this is their online map which shows all the electrical car charging stations around Helsinki in Sweden. Now this application is developed for Scandinavia, which is Sweden, Norway and Finland. A lot of British tourists in Scandinavia, so you have an English language interface, but you can change to Swedish, Norwegian or Finnish. This application is an OSGI application. OSGI is not everyone's favourite framework. I happen to like it. It's very good for embedded applications. The reason it's good for embedded applications is, one, you don't need to care about the file system because everything's in your bundles. The file system can be problematic for various embedded platforms. The next thing that's good about it is you get code injection and an object lifecycle. So like Android or Spring, you have a lifecycle for your beans or your objects, and that's very important. So it helps you manage the things like what's happening in the memory, for Java the heap, which is really important when you have constrained resources like embedded applications. Just demonstrate the application quickly, then talk about the interesting points in the code. So we select your language, in our case we'll select English. We have the customer has set everything up, goes to the charge point with his credit card to begin the process. So he selects yes. So then with a REST API, we are talking to a back-end server, and it will know which of these charge points are occupied or out of service. We select a charge point, and we have an option to choose a charging process related to the speed, and we display this information so they can select their vehicle, understand the amount of time it would take for them to charge to get the mileage that they require. So once they can have enough information to select their charging process, we move to payment options. Here they select their payment process, only one at the moment, then they swipe their card, and once they swipe their card, the charging process initiates. Let's run through that process again, this time in a different language. So going through, everything's in Swedish. Repeat the process, everything's in Swedish. We have a Swedish interface, and we do the same as before. Just point out the interesting things in the code. So I'm not going to go into the whole theoretical basis of OSGI, but bundles are what Java 9, very similar to what Java 9 calls modules. We have a bundle. Here we have these packages. These are analogous to a bundle. So each one of these packages will become this Java artifact called a bundle, which is just like a jar with extra encapsulation properties for the jar and extra metadata about the jar. So what's interesting is this is an OSGI framework, and we're using these things called bun tools. So bun tools was the first incarnation, and this is a bun file. So have a look what bun file looks like. So here we say what particular artifacts, in this case packages. So if we look here, we have this charge point package and a lot of stuff in charge point, and then we have this controller packages. So exporting those two packages. We can have a private package which is not exported, which is encapsulated, but I won't go too much into the OSGI theory. We have a build path, so this particular bundle can use this bundle here as a dependency. So this allows me, so here I'm exporting the packages in this bundle. So this is the bundle that handles the payment processor. So when they swipe their credit card, they need to talk to a back-end server. The back-end server is a REST server, so we have a REST client in this code base, and that talks to the back-end server which is a REST server that handles the payment part gateway and information about the charging station. So there'll be a server in the charging station that manages all the connectors. That will talk to the remote server, and then we'll talk to the remote server to get information about what connectors are available and to process the payment with the credit card. And the server in the actual charging station will know how much energy is coming out of the connector to charge the client appropriately. So we don't need to worry about that. We just have a REST client that talks to that back end. Then we have a front-end GUI, which is mainly set up in this bundle. Go to our entry point. We're bootstrapping the JavaFX processor. This is one of the things that's a bit difficult. So we are not running a JavaFX application class. So the way we get around that is by using this Swing embedded JFX panel. So this allows us to bootstrap the Java application bootstrap code, which handles the video display, handles all the behind the scenes stuff that JavaFX gives you to create a GUI. So we bootstrap that in this code block here. And here we have a OSGI dependency injection. So we have this bundle context, so you can think of that as being very similar to a Spring context. We can inject with OSGI injection. This is using Apache Felix. And we have these extra service registry type injections. So when we're using OSGI, it's not really context injection, it's a service registry type of injection, which is a bit different. And a lot of people actually like that because they think it's more efficient. And because it's an embedded application, we need it to be efficient. So OSGI, once again, really shines for embedded applications. I mentioned before, we have injection from the OSGI framework. So we have a service registry, which is sort of like injection. And then we have an object lifecycle. So here we have a start, so when the bundle is deployed to memory, we start. And when the bundle is removed from memory, when the bundle is no longer required, we have a chance to clean up. Try and make sure we don't have any cyclic references to objects. In a way, we want to try and help the garbage collector by calling destroy on objects so that we don't end up using too much memory. So we have a life cycle, which is really important. Another thing we have is events. Here we are using OSGI events, which we can set up as a pub sub subscribe, very similar to what we were doing with Enterprise Java. So we have these topics, and so we can qualify events with topics. So here I'm setting up events. So here is an event which we can use for the back button. So when we hit that back button and return to the entry screen, and when we want to reset, so we start a new process. So there's occasions when we want to reset the application. Just quickly talk about the REST API side of things. So we have a REST client. This is just using HTTPS URL connection, nothing fancy to keep the dependencies down. Now it's a typical XML endpoint, very similar to when you work with a SOAP API. We have a typical XML payload, so this is what the API returns. So this is a REST API, so this is a server that understands the charge point connectors. So it's a server in the charging station. It's got information about all the connectors. So what is the actual languages that are available in the connector? Is it in service? Is it out of service? Is it available? So all this information comes back via this XML payload. So to deal with that, we need to first create an XSD file. So this is a typical XSD file for the payload. Then we have a process, here I'm using AND, to generate all these beans. So all these beans here are auto-generated from the XSD. And I can use this to marshal and unmarshal the XML data coming from the REST endpoint. And this is for the connectors. So there's two parts to this process. There's the connector information and there's the payment processing side of things. For the payment processing, this is implemented via MQTT, which is a well-known messaging protocol. IBM has MQTT service, open source code servers that handle really high throughput messages with handling back pressure really well. MQTT is a good protocol to use, so it's implemented in the code. So we have a service, an MQTT subscriber. This is our subscriber, so we can subscribe to MQTT topics, which we set up. MQTT topic, which is the pay call. So when they swipe the credit card, we create a message. We subscribe to that topic, so we push the credit card message with the credit card data to the MQTT server, and if everything checks out, then the actual charging process can continue after the swipe, and the information, the amount that they need to pay is charged to their credit card. So that's how we handle the payment processing via MQTT. Some final interesting points to note. It's quite difficult to get JavaFX to work with OSGI, but it is possible, but there are a lot of parts that you need to adapt to. So firstly, we don't have the concept of a file system, so everything's working from the bundles, so we need to wire up the class loader. So here we set the class loader for our FXML layer to be working with the actual bundle class loader. So here we are getting the bundle class loader, so we need to push that into our FXML loader, or we won't be able to find the XML files. So here are the XML files, so they're going to exist in the bundle, not the file system, so we need to get them from the bundle with the bundle class loader. OSGI gives us events, so we can wire up events. So this is the syntax for getting the events. There's a bit going on with bundles, so we don't have the file system, we have bundles. If events, we've got to work with the bundle event system, which is really the OSGI event system. But once you get past those little details, everything works really well, and it's a great system for embedded applications with JavaFX.